Right. Eminent Professor B. Sakram sir, Department of Chemistry, Usman University. Now I request Professor K. Pramila Madam, Head Department of Chemistry, please come into the dais. And our sir, Chief Guest, Sakram sir, please come into the dais. I request Praveen, please present the bouquet to family to guest.
Cover
this. Now I request Pramila Madam, please give the opening remarks for the program.
Respected Professor B. Sakram sir, and my colleagues Kotesrao and Praveen, Mohan, and my dear students. Good morning. I warmly welcome you all to today's extension lecture on determination of reaction mechanism. I sincerely thank Professor Sakram sir for kindly accepting our invitation and taking time to be with us today to deliver this lecture. Before we begin the lecture, I would like to briefly mention the purpose of organizing such programs. The Department of Chemistry regularly arranges extension lecture to enhance knowledge in chemical sciences and to provide students with opportunities to interact with eminent academicians and researchers. Such interactions help in strengthening scientific understanding and in developing scientific temper among students, particularly those pursuing chemistry. I encourage all of you to actively utilize these academic opportunities. Coming to the theme of today's program, the determination of reaction mechanism is a fundamental concept in organic chemistry. It focuses on understanding the step-by-step pathway through which reactants are converted into products. By examining factors such as reaction, kinetics, formation of intermediates, stereochemical outcomes, and isotopic labeling studies. Chemists are able to identify the sequence of events occurring during a reaction. Such mechanist insights are essential for predicting reactions, behavior designing, efficient synthetic strategies, and developing new chemical process. Therefore, the study of reaction mechanism plays a crucial role in both theoretical understanding and practical applications of chemistry. Now I request Kotesrao sir introducing our chief guest.
Now I request Praveen sir, please introduce our guest. Yes. He was prepared.
Good morning, all of you. Respected Professor Pramila Madam, Professor Sakram sir, and dear colleagues and my dear students. It is my privilege to introduce our guest. Dr. V. Sakram is Professor of Organic Chemistry in the Department of Chemistry, University College of Science, Usman University, Hyderabad. He obtained his MSc 2002 and PhD 2006 in organic chemistry from Kakatiya University. He began his professional career as a technical officer at Indian Institute of Chemical Technology, IICT, Hyderabad, for 1 year. In 2007, he joined Usman University as an assistant professor at the PG College, Mirzapur. He was transferred to Nizam College in 2013, where he served as in-charge head of the Department of Chemistry for 2 years. In January 2022, he joined the University College of Science, Usman University, Hyderabad. He also served for more than 2 years as additional control of examiners at Usman University. Professor Sakram has over 23 years of teaching experience and research experience. He has published 53 research papers in requested national and international journals and has presented more than 38 papers in national and international conference and seminars. Under his supervision, 6 scholars has been awarded doctoral degree, while 5 scholars are currently pursuing their PhD. In addition, 12 postgraduate students have completed their dissertation work and 6 students are presently working on their MSc dissertation research under his guidance. He is a life member of Indian Science Congress Association and the Indian Council of Chemists, and also serve as a reviewer for several repeated scientific journals. His research interest including organic synthesis and biological evolution of heterocyclic compounds, particularly the synthesis of novel complexes and their molecular modeling studies. He has completed one minor research project and is currently leading a major research project founded under the SURE program of the Science and Engineering Research Board. Thank you.
Now I request Sakram sir, please take over the session.
Good morning, one all. Respected Professor Kamila Madam and Koteswara sir, as well as earlier my colleagues Mohanbab sir and Praveen sir in Nizam College at that time year to 2013. And my dear students, this is a great moment to stand before you as a guest lecturer. Yeah, as you know about the chemistry, in that basically there is a reaction means, reaction mechanism means, and how to determine the reaction mechanism. I'm going to try to know about these terminologies. I will try to my level best. The pointer is there.
Presentation PDF. Done.
Let's start. Let's-
Sir, damn a point appendix.
Okay, then most.
More. OCs.
Yeah, let me start. Yeah, as Madam introduced about today's lecture, that is determination of reaction mechanism. Means we will try to know here the pathways of reaction, how it is happening, means what are the starting materials generally we will use, and what happens between the starting materials, and what is the role of catalyst, and what is the role of, sometimes we will use solvents, because most of the compound generally a researcher or a chemist start with solid, at least one compound, or both are solid compounds. Due to that, we will use solvents to dissolve them. Later, what happen after dissolving means they will go each other by what we can call the reaction. It means it reacts undergoes means first of all it undergoes bond breaking. Later again new bond formation takes place, and to produce that a new compound. Okay, we will see these one by one. Yeah, let me see here there is a reaction. That is methane reacts with chlorine and gives us what? You can see that there is a chloromethane as well as hydrochloric acid. Yeah. By seeing this, we can know about that two questions, but how it happens, what is the actual initiation, and in what order it is undergone, we will so see in the next slides. By seeing that, you already know about the is basic. Due to that, you can tell that. But otherwise, what happens? Several questions arises. Yeah, first of all, first question, that is what happened in this reaction means we can tell that answer. There is a formation of methyl chloride and HCl, and it is by the reaction of methane and chloromethane. Yeah. Then another question, how the reaction has happened. So now to answer this question, we will see the next line. We see it means we are interested in knowing the theory of the reaction. Yeah. An answer to these questions is known as what? Reaction mechanism. Yeah, that is our topic. What happened there? How it happened? All that we will try to know. That is called as what? Reaction mechanism. And here we can see some more questions. Yeah. The definition of reaction mechanism means what? As just we discussed, I just give a few words. That is what a complete description of a reaction with reference to so many questions are raised. To answer them, it will called as what? Reaction mechanism or determination of reaction mechanism. Yeah. You see that how many bonds are broken in a reaction. So in what order it happened? Means which one first bond breakage takes place, then which one the second, which one third, like that. After bond breaking, what happened? Some intermediate formation takes place. So in that again, what happened? Yeah, new bond formation takes place. At the end, new bond formation takes place. But prior to that, you see the second Again, question, how many new bonds are formed? Then, in so which order they are formed, means which one first form, which one second form, like that. And then, what is the role of catalyst? Sometimes we use catalyst, what is the role of it? And then, role of solvent molecule. As just I told you in the earlier, what happens, we will use solvents to dissolve the starting material. So what is its role? And as well as that, you see what is the role of each step in a given reaction. There are several type of reactions we are going to see in the next slides. Means what happened in the each step. Okay, then the position of all atoms at each step means maybe saccharans are may stand maybe right side sometime. Due to the presentation, I am standing right side. Podium is this side. If it is a normal class, I want to write left side to go right side, then come to again left side, right side, like that. I am writing again upside down, again downside, like that. What happened? In the process of the reaction, on a molecule structure, some bonds are again what happened? Firstly, breaks takes place, then bonds are forming takes place. So in such process, what happened? These atoms are maybe changes their places. So it will also will know in this reaction mechanism. Yeah, why what energy changes are taking place in each step of the reaction? Means the starting material may they before going to bond breaking, what happened? They gain some energy. That is called as what? Activation energy. And then it will convert the starting material convert to what? We can call that intermediate. Then what happened? The starting material may have some energy level, then intermediate may have different energy level, then transition state may have different energy level, and at the end, the energy level of products in a different manner. So at the end, what happened? We will get the product, means that energy level is very, very low. Due to that, it's stabilized. We can get at the end a product. So that what happened, the energy level changes in that process. That also we can see in the determination of reaction mechanism. Yeah, we can see some different type of organic reactions and how the reaction initiated means how which bonds are breaking. Then bond means there are again, we can classify that homolytic bond fusion, heterolytic bond fusion, like that. Then different type of intermediate species of formation takes place. We are going to see there in the next slides. Yeah, you can see here there is a bond breaking. Yeah, in the first one you can see that yeah, I think are you able to see? Yeah, this is the first you can see that there is a tertiary carbonyl group. It is the carbonyl group. It is there. That is like what in this. There is a CY bond, and here you see there is a bond breaking. Means again what happened? The homolytic fission. Homolytic fission means what happened? There is a bond formation. Means what? There are the two electrons. The two electrons come to nearer. They are what? Yeah, hold together by a bond. It is called maybe it is single bond or maybe sometimes double bond, maybe sometimes what? Triple bond. Suppose all are there single bonds, as you know that what saturated compounds. As you know that there is a carbon, it can bond how many single bonds? 4 single bonds. Means catenation of carbon is 4. Due to that what? It will make 4 bonds. Due to why? Octet, yeah, octet rule. As you know the periodic table, there is a periodic table, there are so many groups and so many what? Like in that what happened in the right hand side, last one that is what? 0 group. So helium, neon, like that. So such type of electron are there, they are more stable. Like we can call that what? 0 group elements. Means they fully satisfied. They need not to go any atom or substance to react. So remaining all the atoms try to get that configuration, octet rule configuration. Due to that, in this sequence, what happened? Carbon atomic number is 6. So it may convert as like a helium type or may convert as neon type. Which one is nearer? Yeah, neon, it is nearer. Due to that, it will share that lone or a single 4 electrons with other atoms and like it will get that octet rule. Like that, it is forms 4 single bonds. Yeah. In this part, what happens is there is a bond and it will formation breaking takes place. Means what homolysis means what that 2 electrons are again takes by this carbon 1 electron and that Y is 1 electron. Due to that, such type of fission takes place. Then what happens? You can see that the right hand side. You observe this. Yeah, you better give me a pointer. Okay, bond is there and due to the 2 electron, okay, combined nearer or come nearer due to that the bond formation takes place, here fission takes place. Right? Yeah, then what happened here, the 1 electron may takes for this carbon and 1 electron may take this Y. So free radical formation takes place. Yeah, like that, this is homolytic fission. Then come to another bond fission, that is heterolysis. Means both are not equally shared. One is takes both the electron and another atom loses both the electron. So which one gain? That is called as what? It is converted as C minus. If it is C minus, then we can call as carbon anion. Carbon anion. If the electron loses, then what we can call? Carbocation. If it is carbon. Like that, what happened? Carbocation formation and Y minus. Suppose maybe Y minus means it is having electron more. So that is called as nucleophile. Right, like that. Yeah, then come to the another type. You see what happened here, the bond and electron both are taken by the Y. This Y atom, due to that it is Y minus. If the both electron if takes by this carbon, then what happens? This C minus. Carbon anion, carbocation, like this formation takes place. This is the what as basics we can know that how the bond breaking takes place. And then how the bond formation takes place. Yeah, as the bond breaking takes place, there are several species are formed. Like we can call that these are the what reaction intermediates. And then again we will call that free radicals, again electrophile, nucleophile, electrophile means +1. Nucleophile means -1. Like that again they come to nearer. Again what opposite type. If minus is there, it will form a bond with what plus. Like that what happens minus means the lone pair electron is there. Plus means there is an empty orbital. It will come and occupy that orbital, then bond formation takes place. Like that it happened. So this is free radical bond, but making bond formation. And you see here ionic. So this Y minus it is going to bond form with this carbocation, like this bond formation. Again, here what happens? There is a plus, and this is a minus. Minus means excess electron, nucleophile. Plus means electrophile. There are no electrons. So you should compulsory show the arrow mark from the minus to plus only. Yeah, due to that, minus to plus bond formation. Again, this is minus here. So minus to plus bond formation. Like that it happens. So bond breaking happened like this and bond making happened like this. Now we are going to see the next slide. That is some examples. Yeah, may I audible from here? Yeah, no problem. Yeah, now we will see in the slides some type of organic reactions. As you know, this is the addition reaction, and this is the elimination reaction, and then substitution reaction, and the rearrangement reaction. Yeah, within 1 minute, I will tell you the definition. This addition reaction means, as you know, addition means what? That same meaning. Means addition. Addition means more than two. Yeah, they are adding each other. Like that it happened. And in the chemistry, coming to chemistry, what happened? Generally, it occurs in the unsaturated compound, means alkene or alkyne type compound. Okay. So here you see this is a olefin. Due to that there is unsaturation, there is a double bond. You can add another substance. Then what happened? Like as we see in the earlier slide, like again bond breaking, bond again. What happened? Bond breaks takes place like that. Maybe it will follow any type of it. And generally here in the olefin, what happened? The electrophilic substitution reaction or nucleophilic substitution reaction, it is undergoes. Again, electrophile and nucleophile means, as I just told you, electrophile means what? Plus, there is no electrons. Nucleophile means what? Yeah, there are the electrons, right? Like that, they undergo the reaction. Yeah, you see here, like that, it bond breaks and then addition takes place. You see here, this is one may breaks, then what happens? Nuclei undergoes what? As just we see in the earlier time. Maybe like one may plus and one may minus like that. Or like that it happened. Due to that again, the bond formation takes place. Like that, here you see these two groups are added. Now unsaturated compound is converted to what? Saturated compound. This is what? This is the addition reaction. Then come to the what? Elimination reaction. Yeah, eliminate means what? Remove something. So there is a molecule. Means this is a molecule. See, this is a molecule. It is a saturated or the single bonds. May sometime in the olefin also elimination takes place. And it forms what? Double bond olefin again takes place with remove some group, it will convert to triple bond. See triple bonds. So then again comparison in alkyne, alkene, alkane. We will see there the reactivity. Which one goes more reactive? Means again what happens? More saturated, it will undergoes more reactive. Compared to alkene is more reactive like that. Like that means there are some conditions are applied. Means actually this CC single bond it is more shape. Okay, just we are going to see here only on definitions. Means you see this is elimination reaction with some atoms. Or maybe sometime what happen? Or may a group, a phenyl group, or maybe an O2 group like that. Or it may be a different isopropyl group or alkyl group, ethylene, or maybe like that. Some they are eliminating from the molecule. Like that, what happened? A single molecule converted to two molecules. That is elimination. Means in the main molecule we are eliminated something. Means some atoms or some groups. Such type of reaction. They are coming to another one, that is what? Substitution reaction. Yeah, substitution reaction means in the same molecule, an atom or a group, we can substitute with another atom. Substitution. Substitution means what? If there is a thing here, we just remove it and we can put there another thing. Like that. Okay, we are not totally removing it, or we are totally not newly adding that, not there. Only we are substituting. Means one group is good. Our atom we are substituting another. Like that. You see here, there is a Y, it is substituted by what? Z. This is substitution. They are coming to rearrangement. Rearrangement also what happened here? Within that molecule, Sakram sir has in his upper bracket, there are the pen and spads. He will from here to Put in another phase, another pocket, like that, within the same molecule. Within the same molecule, what happened? From one place to another place. It is happening. It is called as what? Rearrangement reaction. That is called as rearrangement reaction. Yeah. Is it right? Next, ideal. Yeah, then coming to. Okay. Yeah, in the determination of reaction mechanism as on today, there are two mainly you can separate them. The first one that is what kinetic method determination, and the second one that is non-kinetic method determination. Yeah. You see, the first one that is kinetic method means what there are the chemical kinetics. We are by the help of chemical kinetics, we are trying to know that what type of reaction mechanism it is. Maybe it is a what first order reaction, maybe it is a second order reaction, maybe it is a zero order reaction like that, or maybe it is a third order reaction like that. We will determine by this method. What method this is? Kinetic method. Yeah, you can see here, as you know, you say the unimolecular means what happened? There is a starting material. There is a starting material. Yeah, this is the
Okay.
real. Yeah, no problem. You see here, A is there is a starting material, it is converted to B. If what happens, unimolecular means only one starting material, it will depends. The reaction rate, it depends only one starting material. If the reaction rate, it is may depend on the more than one starting material, means two starting materials, so it is called as bimolecular. Only one starting material it is depend, that is called as unimolecular. Like that we can decide. Yeah. Then we will see some terminologies here. Before going to see some example, we will see some terminologies. Yeah, you see that the molecularity. The molecularity, you see, in this molecularity means the reaction, it is may under. Yeah, the number of molecule species that taking part in this slow step. Just now, as I told you, in a reaction process, how many type of reactants or starting materials are participating, their concentration, it will tell us molecularity. Yeah, and we can give the definition in another way, the number of molecules which are involved in the formation of transition state. What is transition state? Again, we are going to see some examples. Means the reactant may get maximum energy a certain time and it will convert to product. Means how many starting materials or reactants are they gaining the energy, highest energy, they are called as what transition state. So then you see that the point of reaction where reactant molecules are going to have maximum energy. So that is called as its transition state. Then coming to energy profile diagram, means this will tell us the total reaction process. What are the starting material, how much energy it has, then how it is gaining the energy, means how much energy it will gain. May it stay some time or may in that time means survive some time. That in the survive at that position, maybe it will cation or maybe it will anion or maybe it will show us, or it will give us an intermediate, all are we will see there. And at the end, what happened? It will convert to totally product. Yeah. Then you can see that another terminology, the intermediate. The molecule species have that is positive or maybe negative. If so, it will serve sometimes. It will called as intermediate. Yeah, then as in the earlier slide we saw that what bimolecular, leading molecular reaction, okay, or third order reaction or zero order reaction, like that we will classify. And I am going to tell one two examples here. First of all, we will see that second order reaction. Yeah, second order reaction, especially you see that it is undergone that bromomethane react with base, it will convert in as what? Methanol. Yeah, in this process you see here, this base it is going to attacking on this and simultaneously what happen? It will, yeah, Br minus diluting. As I just we discussed what there are type of reactions. In that what? Addition reaction, elimination reaction, substitution reaction, rearrangement reaction. Then coming to what? Substitution reaction. Means what? In a molecule, what happened? One group or maybe some atom, it is replaced by some other. That is we are going to see. Here you see Br minus. It is substituted by what? OH minus. Yeah, and this is Br minus, it is going in. And OH minus is coming in. It means what? Slowly it is going to approach this carbon and slowly the Br minus is what we can call going to dissociate, leave. Like that it happened. And this is what you can see, this is called as a transition state. Transition state. This is called as a transition state and this is the starting material. What happened? At the end, what happened actually? Yeah. And you know the umbrella flipped. Is it inside out? While in the rainy season, if we are going away with a umbrella, suddenly a wind or strong wave will come. What happened? Umbrella it is a down to cover us. But by that wind, what happened? It will, yeah, reverse. That is called as what? Configuration reverse. The configuration is changed. So from this backside it is came and it is leaving from right hand side. Due to that what happened? This carbon configuration change. As you know that RS nomenclature. Okay. But if it is configuration change means what? If earlier it is R, then it convert to S. If earlier it is S, it converted to after reaction complete in the reverse one. Like that it happened. Yeah. And what happened here? You see here rate of the reaction is depending on 2-bromo butane we are going to see in the next one. But in this what happened? The rate of the reaction only depend on this starting material, only one starting material. And then this one we are going to see sir. Yeah. Just a minute. This is what actually we are under second atom. Due to that, the two starting material both are showing their importance in the reaction rate. If may reaction slow means what happened? Both are participating. If the reaction fast means both are participating. And like that we can see that. Yeah, we will see another example and try to know about it more. You see the same type of another example like which here you see this is same what the bromo substitute. Okay, that is the tertiary one and it is reacting with the base. Yeah, simultaneously what happened? We are minus everything and OH is introducing inside, coming inside. The same you see what happened, right hand side is the bromine, at the end what happened? The left hand side is the newly came one. So configuration changed. And in this what happened? The reaction rate is depending on both the starting material. Due to that it is a bimolecular reaction. What we can call? Bimolecular reaction. It is depend the concentration of two starting material. Due to that, it is what? Second order reaction. What? Second order reaction. Yeah, the same one we are going to see in via the energy profile diagram. There is another diagram here that is called as energy profile diagram. The same reaction we can understood by the energy profile diagram. Yeah, this is the energy and this is the process of reaction or reaction coordinate. What happens in the starting? Yeah, earlier what happened, here the reactants are there. Both are what? Reacting together means some disturbance it is there. They are not stable. They are not what? Recognize each other and not allowed to stable them. Due to that, what happened? Reaction factor. Otherwise, you have added some catalyst or you have added some solvent. Due to that, what happened? It will undergo the reaction. Means it will take some energy. By that, what we can call that activation energy. That one, it will gain some energy and it will reach to a transition state. Yeah, this is the transition state. Means what happened? Earlier, this is the you have maximum energy now. And after some time, what happened? It will convert to product. So again, what happened? Energy? Yeah, energy is going down. Means it is more stable now. Compared to the starting, compared to the product, what happened? Product side, very low energy. Due to that, the product will come up. Then we can isolate it. We can take, filter it. We can take in a bowl. We can take in a or filter it like that. Yeah, this is the what? Second order reaction or bimolecular nucleic substitution reaction. Yeah, and this will by this energy profile diagram we can see that you know that the waves of the what electromagnetic and what it is like that crest and close you know. By that also we can by seeing this energy profile diagram we can tell that how many step reaction it is. Yeah, you see here this is the starting material means reactant, this is a transition state, this is a product. Now coming to the you see one up is there means what it is a crest. So you see the energy profile diagram of a second order reaction contain only one crest. Therefore, it indicate what? One step reaction. Then the same step what happened? OH minus is coming and simultaneously Br minus is getting. So within only one step, the reaction is up. So this is one step reaction. Yeah, we'll see another example here. This is the another example. You see, this is a SN1 reaction. Yeah, this is the first order reaction unimolecular. The SN1 reaction, you see the first and the rate determination slowest step is what? It is a two-step reaction. You can see here there are the two arrow marks. Here and it means again the binary and here the product side. Yeah, now we can see that what happens in the rate determination step means what? That is decide the reaction rate. In the rate determination step, how many reactants are involving in that? So it will tell us it's molecular. Like that, this is a substrate, and by leaving there is a group. What happened? It will convert as a intermediate, and in this special, this one what happened? The LG means leaving group. After it elutes, means along with this bonding electron, it will convert as carbocation. Yeah, later what happened? Yeah, that another nucleophile. Nucleophile is one eluted. Means what? Another nucleophile also its place. Like that it is coming. Means what happens? This also comes under substitution reaction. Because there is a nucleophile eluted and the new nucleophile added. Means coming in that place. So it is a substitution reaction. But especially this reaction is its reaction rate is where it depends only the concentration of substrate only this starting material, not on this coming nucleophile. But the earlier one, it depends on substrate as well as the base. Due to that, it is a second order. But this is a first order. Due to that, rate is now you see the concentration of the substrate only. Okay, if the substrate doubles, then what happens? Rate doubles. If we are increasing the substrate, the concentration of the substrate, what happens? Reaction rate is also double. Nucleophile has no effect on this. If we are adding this more, the reaction rate is not changed. The same, it will happen. Yeah, we will see one example. Earlier one, it is a outlook to example. This is, we can see that one example. Generally, the tertiary alkyl halides are undergone this SN1 reaction. You see that first one. You see, like this is a Br minus in the rate determination step, and it is called as a source step. What happened? Br minus eliminated. Then what happened here? Carbocation formation takes place. In the second step, the nucleophile is coming. And in earlier reaction, it is a inversion takes place. Configuration change. But here, the same side, nucleophile same. So configuration is called as retained. Configuration is called as retained. And as I told you just in the earlier type, same I will tell you. Here what happened? Earlier there is a one thing, and later another thing came. The same place, not the other place, same place. So due to that, what happened? It is a retained configuration. And you can see that it's what we can call that. This is what, by seeing that graph, energy profile diagram. By seeing that also we can tell it is a one-step reaction or two-step reaction. Yeah. Can you guess now? Yeah, it is two-step reaction. You see, these are the starting material. One time it is got what? Transition state, highest to maximum energy means it will call as maximum energy, one called as what? Transition state. And it loses some time energy. And it will came here, that is called as what? Carbon cation. After first step we got that is an intermediate. Means it has some lower energy. It is called as what? Intermediate. We can isolate sometimes in such type of reactions. Later again what happens? It is not stable. In the second step what happens continuously? It will take another transition state. So suppose what happened here that tertiary butyl bromide it is there. Later what happened? It loses some energy and it will now converted as carbocation and Br minus, as well as there is OH minus also there, and here it will attach OH, namely OH one nucleophile attachment. Later it will convert to protein. Yeah, by this electrical diagram we can tell that how many crests are there and how many throws are there. Depending on them, their number, we can decide how many step reactions. You have seen what? Two crests are there, right? Due to that, it is a two-step reaction. Two crests are there. Due to that, it is a two-step reaction. Yeah, energy profile diagram of the first order reaction contain what? Two crests and one flow. Due to that, we can tell that what? Therefore, they indicate two-step reaction. The energy profile diagram of multi-step reaction contain if what happened? Many crests, many flows. By seeing that energy profile diagram also, we can tell that what type of reaction it is and how many steps are involved in that reaction mechanism. Also, we can tell. If many step reaction and if it is there, what happened? Many crests will show and many flows. Yeah, and we can same kinetic by the use of up to here we are not able to understand that reaction. We will additionally we will take some other experiments. That is what kinetic isotopic effect. As you know that isotopes of the hydrogen, then deuterium like that, and carbon 13, carbon 14 like that, and chlorine 35, chlorine 37 like that. Some isotopes are there. By using of them, we can try to know that reaction, what happens in that reaction mechanism. Yeah, if suppose we can take that there is an example, you see, there is a CH bond and it will converted was that H is replaced by this Z. And if there is a hydrogen deuterium, isotope of the X, it is a deuterium, then it is substituted by this Z. If we will compare this reaction rate, then what happens? This is the faster one. Earlier one, the faster one, compared to the second one, it is slow. See, second one is a slower one. While the deuterium is a yeah, like that we can understood. No problem. And again, it what means the CH that what you can call activation energy, it want lower one. Because the heavy compared to deuterium, it is a smaller. When compared to the hydrogen, deuterium is a bigger. Due to that what? It want activation energy more. So the reaction rate is a comes slower compared to that. Yeah, like that we can classify. Yeah. Then we can tell that again it is again we will divide into two types. Primary kinetic isotopic effect and secondary kinetic isotopic effect. Yeah, same one we are going to see here. You see, if the cleavage of CH is suspected in some reaction, whether the CH is bond is suspect means cleavage may undergone the rate determination step, slow step or fast step. Try to know it, we will bring this kinetic isotope. That means we will take its isotope, means deuterium instead of hydrogen, we will take deuterium and we will compare. Like that we will know. Yeah. In this process of the reaction, with the rate of the reaction which deuterium contains, compound is slow, then we say there is a primary pressure isotope effect. Yeah, just as we discussed here, what happened? The reaction rate of if it is CH bond faster, if it is CD bond, means deuterium, is slow. Right? This means why it is happened, and we just now we discussed. What is that? Yeah, due to activation energy, it want more. Yeah, if there is a suspect, that means the CH bond is maybe broken or the bond breaks in the slow step or not. To determine it, we will take one example. You see, this is a bengaldehyde. When we are doing the oxidation reaction, this bengaldehyde, this aldehyde is converted what? Acid. And then the second one, we are replaced or we are changing that isotope by this one hydrogen is replaced by deuterium. And we compare. Okay, in the place of that H what? We already taken the deuterium, we do that deuterium. Yeah. When this CH bond is replaced by the CD bond, in Bengali, kinetic isotopic effect was observed. You can see that. Yeah. Therefore, in this our reaction, slow step involves the cleavage of CH bond. Okay? It will mean what? The rate determination step is decide the rate of the reaction. In that step only, this CH bond is breaking. How we will check it? If we will replace this with this isotope and compare the reaction rate, then what happens? This reaction is faster and this reaction is slower. Due to that, what happened? We can decide that CH bond is breaking in a rate determinant step only. Right? Like that we. Yeah, this is now secondary kind of isotope. Yeah, it is the same one what happened if we will see that the same type of reaction earlier we saw. But here instead of that bromine, we are taken here chlorine. Yeah, the first step what happened? Carbon-cation formation. The second step what happened? The nucleophile. Means here nucleophile gone. And in the place of that, new nucleophile came. Right? And in the first step what happened? Carbon-cation formation takes place. And then in the second step, what happens? Nucleophile gives product. Yeah. Now we are going to see now secondary kind of isotopic effect. Means what? In the rate determination step, that CCl bond is not breaking. It will try to know it. We will take its chlorine isotopes. You see, chlorine 35. And another one, chlorine 37. And we will compare which reaction is faster, which reaction. Okay, you see now what happened? If in the rate determination step, it happens, what happened? Earlier one the faster and second one is the slower. But what happened is, the rate of the second reaction was found to be slow when compared to the reaction one. So this is the faster one, this is slower. Means what happens? This bond is breaking there in the first step only. But you see, hence the CCl bond is said to exhibit primary kinetic isotope only, not the secondary. Means in the slow step or rate determinant step, if it is bond is breaking, it will comes under what? Primary isotopic effect. Okay? But our heading is the what? Secondary isotopic. But this bond is not came in that. So due to that, we are seeing another example to understand that. Yeah, you see this. Instead of that, we will take, earlier already CS3, CS3, CS3. To decide this, what we will compare now, which means the first reaction, C35 is a faster, C37 is a slower. Okay, then we want to know what is secondary isotopy effect. Due to that, we are taking this exam. Yeah, now what happened? To understand that, we have taken instead of CS3, one of it, CD3, deuterium. And then is a SN1 reaction. Yeah, then what happened? It is a two-step reaction as we discussed earlier. The first step, what happened? Carbocation formation takes place. And the second step, what? The fast reaction, that is second step, and it will give to convert to product. Yeah, like that. So carbocation formation. Right? Then, in the second step, what happened? We will not give our required butanol time. Whole time, we will not give it. What happened? It will given a different path. Yeah. Prior to form that, what is the whole means nucleophile OH10, prior to form that, what happened? Internal. Yeah. Something happened in that. This is like this. There is a what? CD3 bonds are there. One of it bond, you will hear what? There is a carbocation. One of the CD bond, the bond electron convert here. And the D is loses toward this side electron due to that is D minus, D plus. And that is D plus due to that here double bond. So this is like olefin type compound here. So this is now we can tell that means in the rate determination step, the bond is not breaking such type of bond, then it will come. That is called as what? Secondary characteristic. Right? If in the rate determination step it is bond breaking, called as primary acidic. Yeah, we see here that CD bond happened here. In this, due to that, it is a secondary. Yeah, when the hydrogen of one of the methyl were replaced by the deuterium, same we have done here, and kinetic effect was noticed. Such kinetic effect produced by one. By wanting we have taken this, right? So which are not involved in this slow step are known as what? Okay. Yeah, then reason for this, reason for primary acidic effect, as we discussed in the earlier also, this is CD bond dissociation energy is better. To break that CD bond means CH bond type CD bond, deuterium bond. It want what? Yeah, dissociation energy or activation energy what? It want more, greater, higher. The activation of the deuterium compound would be greater in reaction involving the cleavage of CD bond. Therefore, the rates of the reaction slow down by replacing CD bond by the CD, CH bond by the CD. So which one faster, which one slower? If the dissociation CH, it is a faster reaction. If dissociation of CD, it is a slower reaction. Yeah. Then we will see some suspension reactions are there. Then we will take the help of this isotopic labeling. Yeah, isotopic labeling. If there is a reaction, you see here there is an example. This is an example. You see amyl ester. You see this one, and there is a doubt. What happened here? You see C double bond O C2H11 C5H11, and it will react with water. The water is isolated. That isotopic oxygen. That is 18, and we are going to breaking this bond, means the ester bond breaking. As you know that ester is reacting in water, what happened? It dissociated as alcohol and carboxyl. But which bond is breaking? So here you see maybe this acyl side or maybe this alkyl side. This is called as what? Acyl carbon. This C double bond is CH3 C double bond, it is called as acyl carbon. So such time if it is break here, this is acyl breaking. If this is what? Alkyl. So this side there is another CO bond is there. Maybe this also undergoes. If it is undergo breaking or fusion takes place, it is called as what? Alkyl bond breaking. Some doubt is there. So due to that, we will take the what? The reacting water will contain what? It is a isotopy one. Then By seeing this reaction, we can tell now, this is the, where the bond is breaking. Where the bond is breaking, so isotope one came into the acid, right? And the normal one came out. Means which bond breaks? This bond breaks. Acyl bond breaks. So I am, yeah, just shown as a tick mark. This is break, and this is not break. Yes, this bond is undergone degrade. Means acyl bond is breaking, not alkyl bond. This is called as alkyl bond. This is called as acyl bond. Both are bond with this carbon and this O, and this carbon and this O. This is not this. So we will take the help of this isotope labeling. Like that, we can determine the reaction mechanisms. The same one we can see in this slide also. This one, not this. Instead of that alkyl total group, we have taken here R dash. This is happened. Right? Yeah. If you have so many doubt again, we will take this experiment in the determination of reaction mechanism. We can use that isotopic labeling, primary kinetic or secondary kinetic, isotopic like that we can determine, or we can determine with this cross-over experiment. Yeah, as we know that we want to go overtaking. Why we are overtaking? Some other person are overtaking. Like that, what happens? Some intermediate formation takes place, but it not survive more time. So that intermediate formation takes place very low, means low amount. So we will trap it with some other substance and we will identify. Means whether it is formation takes place or not. To determine that, we will follow this. What? Crossover experiments. Yeah, you can see that there is a rearrangement reaction. This is what? This rearrangement reaction. Yeah, generally it will give what happened here. The bond breaks takes place, and this methyl group comes here, right? And this is converted as OH. Yeah, this is suppose same type of molecules we have taken in the same bowl, right? If it will give a normal product, it will give a cross product. By that we can tell that it is a intramolecular reaction or intermolecular reaction. Intra means within the same one it happened. As just we taken one example, same from upper bracket to lower bracket type. That is what the same person, only it changes. Generally you want to put a mobile, yeah, it is fine. Okay. Somebody, yeah, put it, yeah, upper bracket or shade bracket. Yeah, like that. Means what happened? We just changed it from our shade bracket to point bracket. Same person. So that is called as what? Intramolecular. Intramolecular. If my packet to some other teacher faculty packet, or maybe I will give my phone just hold some time, means like that I will give you, you can take in your packet. Means what? Inter. That is inter. Within the same intra. If it is formation intra or inter, to confirm that we will do crossover experiments. Like that, suppose the same type of compound it is there, slightly changed. This is what actually it is a ester, this is also ester, this is what benzyl ester, this is this is also vinyl benzoate, and this is again naphthalene ester. Right. What happened here? The SI group it is removed here and it will come to the here to more stable here. And same it will like this dissociation takes place here and it will come to here in the place of this one. Yeah. In the same type, this benzyl came. The same molecule. You see only one ring. Okay. In the same it happened. PNC double bond. Oh, the same one. And in the naphthalene CH3 double bond. Oh, in the naphthalene came. Such type of if products or formation takes place, that is called as what? Normal product. And as we just very good, we are following me. After 45 minutes also we are following very good. You have more in there like that. You should keep it. Okay. It is called as what? Intra. Very good. Intramolecular rearrangement. If sometime this benzene group came to where in the naphthalene, then what happened? It is a cross product. And in this phenyl, one phenyl ring, if this SL group came, such type of product formation takes place. It is called as what? Cross product. Yeah, and the detail is there. Yeah, very good. What is that? Intermolecular rearrangement reaction. Right? This is about what? Transfer experiment. We will see another example here. This is reacted one, unlabeled reacted. This is double reacted two. And what are the cross product? What are the non-cross product? Possibilities are there. You can see that. This is another type rearrangement. Earlier price rearrangement, and this is Claisen rearrangement. Yeah, then only up to here we discussed kinetic method only. Yeah, madam, I will continue 10 minutes. Okay. Yeah, in this method also we will see some examples. Yeah, this is the second method, that is non-kinetic method. In the kinetic method means only we are seeing the kinetics, means a fast reaction, a slow reaction like that. But here, by the evidence, we can isolate some. And then we will characterize it. Right? And we will decide. Yeah, non-kinetic methods. In this, the identification and characterization of product. We will generally here. Yeah, we will take the simultaneous type reactions. Both are looking like same. You see, the first reaction, it is a toluene, this is also toluene. If we are reacting with chlorine, what happens? You will get benzyl chloride. Right? Benzyl chloride. Again, doing chlorination, what happens? Dichloromethyl phenyl. Right? It is a free radical reaction. And then we can see this what? In presence of this FeCl reaction it is. Yeah. Then what happens? It is a nucleophile allotropic substitution reaction. Yeah, as we discussed in the earlier addition reactions, only aliphatic compounds are undergo part addition reactions. But here also some bonds are there, but these are aromatic compounds. Due to that, these are not undergo addition reaction. These are undergo only substitution reactions. Yeah. Due to that, what happens? It is the electrolytic substitution reaction after. Right? Like that, we can see here we can isolate the compounds and we can characterize every time we will try to know it. Yeah, isolation and characterization of intermediates also. Earlier we already saw there only direct starting material product. But in some conditions, in this reaction, you can isolate the intermediates also and you can characterize it and you can confirm it. Yeah. Further, you can take this Hoffman rearrangement reaction. A multi-step reaction may proceed through several intermediates. If such intermediates are isolated and characterized, it is going to be a good evidence of the reaction mechanism. Yeah, we will take one example, that is Hoffman rearrangement reaction. What is actually Hoffman rearrangement reaction? This amide, it is reacting with the bromine and give us what? Actually, this is the product. Amide to amine. Amide to amine. In this process, several intermediates are formation takes. And we can isolate them. Here we are isolating means it survives one time. We can isolate and characterize and we will decide. That is that evidence. Yeah. If we are starting with this and reacting with this, what happens? This formation takes place and it will called as what? N-bromo-amide. Or we are taken due to that amide only. Right. So on the nitrogen is bromine is due to that what? N-bromo-amide. And later it will undergo again OH minus. What happens? Yeah, like this water resulted here. This OH minus take this H plus. And what happens? The bond electron loses here. Nitrogen. Then this will formation takes place. Later what happens? It will loses again Br minus due to here electron rich. So it is easily elute this and it will form this acyl nitrene. Right? Later it will undergo rearrangement. You see, this alkyl group along with the bonding electron and shifted to here, like this carbon get now positive charge. And it will undergo again rearrangement or resonance and it will what? This is isocyanate formation. Now we can isolate this, right? And this. We can giving evidence. Why we are giving evidence means this reaction is following this type of reaction mechanism. That is the evidence, right? Why you are sitting there? Why I am standing there? For what? To learn chemistry. And today class especially learn about what? Determination of reaction mechanism. We have a doubt which mechanism it undergoes. Due to that these evidence. Okay? By forming these intermediates, we can tell what this is the evidence and this is the mechanism follow this Hartmann reaction. Who discovered this? Very good. His name is there. Who is he? Hoffman is there. And he he told us a possible mechanism and by the evidence of this evidence. Due to that we are studying this. Under where to determine the reaction mechanism or pathways of the reaction mechanism. Some other. Yeah. You see, earlier we saw some other type of reactions also under this. If the same time, you see, only just change OR and O R dash. The same time it happened. This is what the designated and you see like this. Amine type. Here bar red, and what happened? And here the fourth position again linked. And if we form a cross product or not, we can try to know it. The same we are going to explain here. Another example. By the isotopic labeling also we will understand is this one. And you see this is a normal one and this is actually the C14 isotope. Okay. This is not C14 CS3. This is C14 isotope. Instead of this, we can actually take the star mark here. Okay. Anyhow, what happens? This isotope C14 one and this is C13 normal. Like that, we can after formation of these products, we can decide whether the cross product is there or no cross product is normal product is there. And by seeing that, what we will decide? Earlier, intermolecular, intramolecular. Cross product formation means intermolecular. Normal product formation means intramolecular. Yeah. And there is another one that is chemical trapping. Earlier Hoffman rearrangement we already saw, and we will able to isolate intermediates, and he given evidence due to that we are studying to determine reaction mechanism. In that we are already studying in the non-kinetic methods, right? But some reactions are there. They also form some intermediate, but we are not able to isolate. Means it will not survive more time. Before we are isolating, it will convert to product. But we have a doubt whether it is formation or not. By seeing the evidence, we will confirm. Oh, this is following this mechanism. Due to that, what happened? We are doing some other chemical adding to that, and that newly chemical adding that intermediate, it will trap. If it is formed, it will trap. And it will give a new type of, not a normal. By seeing that, we are doing this chemical trapping. Yeah, what is chemical trapping? Trapping reactive intermediate by the addition of external substance is known as chemical. Why we are doing this? There is a doubt whether the intermediate formation takes place or not. If you try to isolate it, it will not survive more time to isolate it. Due to that, such type of condition, we are doing chemical trapping. Yeah, we see this. Suppose there is a this type of reaction, and this one, if it is a formation there or not, to isolate, to understood that what happened, this will react. And coming to another example, here you see this is chlorobenzene reacting with this sodamine and ammonia, then what happened? Chlorobenzene converted as NaBN. This is following a mechanism. There is an intermediate formation. You can see that there is a within the benzene ring, one C3 bond C it will come. Benzene. It is called as arine. Benzene. Lastly, YNE. This one. Right? Yeah. This is chlorobenzene. We already saw the actual reaction earlier. This is like mechanism we can understood. Yeah. What happened actually by this NaNH2? What happened? Na plus NH2 minus, that this NH2 minus, it will take this proton and we can isolate here. This is C14, right? Star one. Yeah, like that. What happened? Within the benzene ring, this is sp carbon comes, right? But it is a doubt. To know it, we are doing trapping with this adding such type of compounds. So if this is added, what happened later? You see, this is like that. So this will take, then you see C minus. Later what happened? This C minus again take this H plus, and this chlorobenzene converted as what? NaBN. But it follows what? Via this. This is an intermediate. But to isolate this, sp3 in a benzene ring, it is what happened? Not more stable. Means it is not stable in more time. To isolate and characterize it, not that much time it will give us. Due to that, we are doing the chemical trapping with this. If it forms, then it will give like this. You see. Now, you know Dinkala reaction. This double bond coming like this, and like this one reacting with this, then this will like this and this will like this. Means this double bond between one or three bonds are there. One of it pi bond. First of all, this is connected as C minus, then going on this carbon. Oh, adjacent carbon. Then what happened? Electron rich here. So this is going between these two. Now here rich. So what happened? This is going to attaching here. Like what happened? This formation. We can pull like this outside. Like that, adduct formation takes place. So by forming this, we can characterize this. This is a product. By forming this, because in the same bowl, we are not added this. Only we added this and this. Right? But at the end, we will get this and also this one in the product. By separating it by the different methods, maybe filter or maybe chromatography or maybe like that, or maybe what happened after isolating two components came, then we will characterize it. It also there and it also there. If it is there, that is our evidence. It follows that via this one, via this formation of benzene. Lastly, YNE means triple bond is there. Benzene. Yeah, this is the what? Chemical trapping. Some more are there. You see? Yeah. This is chemical reaction. There is a, you see, there is a, what happened? This is PHCS2OH and PCOH, and we can take a deuterium also, we can know that. What happened in the first step or date determined step or not, and it is happened or not, where it happened, that bond making, all we can generally know by this. At the end of we can characterize them via the spectroscopies. Okay, by the reaction mechanism, determination of reaction mechanism, at the end we should use the spectroscopies and some other chemical reactions. As you are knowing or you are studying this identification of compounds, whether it is a strong acid, weak acid, like base, like that, whether our product is this one or not. In the lastly, we will got something, but it is a correct one or not, target one molecule or not. We will try to know it. This is the last example. You see, and the isotope labeling, as I told you, that is deuterium like that, carbon 13, 14, sulfur, and chlorine 35, that like that, you see. We can use that isotopes, and we will, if there is a doubt, we can use that isotope and we will try to know it. Yeah, if there is a doubt, you see, this is a naphthalene actually, naphthalene, you know, and reacting with the sulfuric acid at 160 degrees centigrade, it will give us what? 2 naphtha. These are the what? Generally fused carbon, and the adjacent all these are called as what? Alpha carbons, all are same. This one, this one, this one, this one, right? Okay, and this second comes the first and second, and this is the first second, and this is first second, like that. Here are 1, 2, and these two are called as what? Beta. So this is what? Beta sulfonyl acid. Naphthalene sulfonic acid, that is beta, or 2. How much it is formation takes place?
85.
Remaining 15. That is what? This one. There is a doubt. Actually, maybe one is 85, one is 15%. How it is forms? Which one forms more firstly? Which one forms secondly? Like that, there is a doubt. Due to that, they taken this sulfur, that is as C35, and they try to know it. But it is happening after that, what this crossword experiment, or we can call that what happened. It is happening, that is desulfonation and resulfonation. Actually, sulfonation reaction or a. It is happening what? Maybe generally direct due to this, but at the end, what happened? It is again equilibrium time. It is doing maybe forward, backward, like this. This is also there, and this is also there. What happened? It is trying to knowing it. We are taking that sulfur as 35, but at the isotope one, it is forming very little amount, smaller amount. Prior to confirm it whether there is a yes 35 it is there or not. Again, what happened? It will desulfonation, one sulfonic acid, 2 sulfuric. It is now also dark. It is what? Sulfuric acid. It is a strong acid. Yes, strong acid. Okay, so it is desulfonation and sulfonation. Desulfonation, sulfonation, it is another process. The same we explained there. But what happened here? If we will use that S35 to identify S35, it is came on the 1 position, or maybe on the 2 sulfonic acid came. Prior to knowing it, what happened again? It will convert to 1 to 2 and 2 to 1. It is again still now down, because it is forming very less amount, right? And that half-life of the sulfur is very low. Yeah, half-life of 84 days actually, but even what happened, very little amount this formation takes place. Yeah. Before going to acknowledgement, if any questions? Right.
Any question? Can plan to.
డౌట్ ఉంటే అడగొచ్చు సార్ తెలుసునే అంటే మొత్తం ఇంగ్లీష్
ఇక్కడ చెప్పదు మన తెలుగే మంచి నీళ్ళు తాగినట్టు అట్లా అనుకున్నారు ఇంగ్లీష్ నేర్చుకోవాలి అవసరం ఇప్పుడు మనకు అన్ని అవసరమే కదా అది అవసరమే అడగండి ఏమేమి
ఫస్ట్ ఆర్డర్ రియాక్షన్ లో డ్రగ్స్ మెనీ డ్రగ్స్ ఫామ్ అయినట్టు ఒక్కొక్క డ్రగ్ కి ఒక్కొక్క క్యారియర్ అయాన్స్ ఫామ్ అయితే డ్రగ్స్ దగ్గర
డ్రగ్స్ అంటే ఏమంటున్నావు స్టెప్స్
అంటే
ఫస్ట్ ఆర్డర్ రియాక్షన్
డ్రగ్స్ సపోజ్ 3 డ్రగ్స్ is formed. Each drug is indicating the ions.
Each drug indicating that crest is generally shows us what higher energy, that is transit state. Through వచ్చి అనుకోండి కిందికి వాటిని ఏమంటాము ఇంటర్మీడియట్స్. Intermediate means maximum not it have maximum energy. Transition state has maximum energy. దాన్ని మనం ఐసోలేట్ చేయలేము. అది తొందరగా మళ్ళీ ఏమవుతుంది, ఇంటర్మీడియట్ వచ్చి మళ్ళీ ప్రోడక్ట్ సెక్ట్ వెళ్తుంది. ఇన్ ద రియాక్షన్ ప్రాసెస్ ఇప్పుడు మనం ఎంతసేపు మాట్లాడుతున్నది స్టార్టింగ్ మెటీరియల్ ఉంది, ప్రొడక్ట్ ఉంది. మనం ఆ టేబుల్ చూపించినప్పుడు కూడా ఏం చూపించాము, ఈ స్టార్టింగ్ మెటీరియల్ కొద్ది గొప్ప ఎనర్జీ ఉంది, జీరో లేదు, కొద్ది గొప్ప ఎనర్జీ ఉంది, అందుకనే రియాక్షన్ అవుతుంది. అయిపోయినప్పుడు ఏంటి, ఇది రియాక్షన్ యాక్టివేషన్ ఎనర్జీ తీసుకుంటుంది, అండ్ ఇట్ విల్ టేక్ ఇన్ దట్ యాక్టివేషన్ ఎనర్జీ అండ్ లాటర్ దట్ వాట్ హ్యాపెన్, ఇట్ విల్ గోయింగ్ highest to maximum energy. It will convert as what? Transition state. If it will show us transition state 2 అంటే దానికి 2 crest. So 2 step reaction. అది SN2 reaction, అది మనం సెకండ్ ఆర్డర్ రియాక్షన్ చూసుకోవాలి అనుకోండి, ఓన్లీ 1 వచ్చింది. తర్వాత డైరెక్ట్ ప్రొడక్ట్. అండ్ యూ సీ దట్ ద ప్రొడక్ట్ వాట్ హ్యాపెన్, ద స్టార్టింగ్ మెటీరియల్స్ how much energy they have and the product how much energy they have, lower the product side. దీనికి చాలా ఎనర్జీ, ఎందుకంటే కైనెటిక్ ఎనర్జీ ఏం ఎనర్జీ లేదా, అందుకనే స్టేబుల్ ఉంటుంది, ప్రొడక్ట్ సైడ్ వెళ్ళిపోయింది, ఏం చేసేది లేదు, చాలు అనుకోండి, సాటిస్ఫైడ్. స్టార్టింగ్ మెటీరియల్ అనుకోండి, సమ్ హౌ ఐ వాంట్ టు డూ సంథింగ్, అక్కడ మీకు ఎన్ని ట్రాన్సిషన్ స్టేట్ వస్తే అవి అన్ని క్రెస్ట్ కింద వస్తాయి, ఎన్ని త్రోస్ వస్తే అవి ఇంటర్మీడియట్స్ కింద. కొన్నిసార్లు మనం ఇంటర్మీడియట్ ఐసోలేట్ చేయకపోవచ్చు, అందువల్ల కెమికల్ ట్రాపింగ్, అది కూడా కష్టం. ఓకే,
ఇంకా ఏమైనా డౌట్స్?
సార్ కైనెటిక్ ఐసోటోపిక్ చెప్తారు సార్, అంటే ప్రైమరీ సెకండ్ ఎట్లా?
ప్రైమరీ కైనెటిక్ ఐసోటోపిక్ ఎఫెక్ట్ అంటే సెకండరీ కైనెటిక్ ఎఫెక్ట్ అంటే వాంటెడ్ గా చేసిన వల్ల. సెకండరీ కైనెటిక్ ఐసోటోపిక్ మీన్స్ అది ఎక్కడ రేట్ డిటర్మినేషన్ స్టెప్ లో జరగట్లేదు. ప్రైమరీ అనేది రేట్ డిటర్మినేషన్, రేట్ అంటే రేట్ డిసైడ్ చేసే స్టెప్ లో జరుగుతుంది.
బాండ్ బ్రేకింగ్,
బాండ్ బ్రేకింగ్
ప్రైమరీ సెకండరీ. అదే సార్. నెక్స్ట్
యా, ఇప్పుడు ఏంటి అనమాట, మన డౌట్ యాక్చువల్గా మనం డైరెక్ట్ ఎగ్జాంపుల్ పోవచ్చు. ఇప్పుడు ఎగ్జాంపుల్ తీసుకున్నాము, సపోజ్ ఇక్కడ చూపించింది ఒకటే స్టెప్ లో మనం చూపించాము, కాకపోతే జనరల్ గా రియాక్షన్ జరిగే ఎట్లా అనుకుంటున్నాం, ఒకటి స్లో స్టెప్ ఒకటి ఫాస్ట్ స్టెప్ ఉంటుంది అనుకుంటున్నాం. ఇప్పుడు SN1 SN2 చూసినాం మనం, అది SN2 ఏమైంది, ఓన్లీ 1 స్టెప్ రియాక్షన్, ఇటు బిఆర్ OH మైనస్ లోపలికి పోతుంది, అటు BR మైనస్ లేదా X మైనస్ అంటుంది హాలోజన్, ఆ న్యూక్లియర్ బయటకు వెళ్ళిపోతుంది. ఇది సైలెంట్ ఏం జరుగుతుంది, ఇది మెల్లగా ఏమవుతుంది, దోస్తానం వద్దండి, దోస్తానం చెప్తేనే కదా ఫస్ట్ దోస్తానం చేయాలి, నాశనం చేయాలి దోస్తానం ఇక్కడ. ఫస్ట్ ఇంటరాక్టింగ్ మీన్స్ ready to interact. We are showing your enthusiasm to make with you friend. It is going to making a bond, and what happened here, bonding is becoming slower, stronger. Weaker to stronger. So what happened, ultimately that loses that. At the point, ఇక్కడ మళ్ళీ సేమ్ అదేంటి, ఓన్లీ 1 స్టెప్ రియాక్షన్ ఎసెన్షియల్లీ. అండ్ ఫస్ట్ స్టెప్ లో ఏంటి, ఫస్ట్ ఆర్డర్ రియాక్షన్ వచ్చేసరికి ఇంటర్మీడియట్ ఫార్మ్ కార్బోకేటైన్ అది ఇంటర్మీడియట్, అది ఇట్ విల్ సర్వైవ్ సమ్ టైమ్, అది సర్వైవ్ సమ్ టైమ్ అనుకున్నాం కదా. తర్వాత ఏమైంది, ఫాస్ట్ స్టెప్ ఏంటి, ఆల్రెడీ ఇప్పుడు ఇందులో ఇంటర్మీడియట్ ఫామ్ అయిన తర్వాత అని ఏమైతుంది, అది రెడీగా అటాక్ చేస్తుంది. అంటే ఏంటి, ఫస్ట్ రోజు అనుకోండి దోస్తాను ఇదే, కానీ ఇక్కడ పోయచ్చు అది ఏమంటాం, యాక్సెప్ట్ చేస్తే పోతాను సెకండ్ స్టెప్ ఫాస్ట్ రియాక్షన్ అట్లా జరిగింది. అది ఇప్పుడు మనం ఇక్కడ ఏంటి, రేట్ డిటర్మినేషన్ స్టెప్ లో ఈ CH బాండ్ బ్రేక్ అవుతుందా లేదా అది మనం తెలుసుకోవడానికి మనం ఏం చేస్తున్నాం, ఐసోటోపిక్ లేబులింగ్ చేస్తున్నాం. చేసినప్పుడు CH బాండ్ ఏం చేస్తున్నాం, CD బాండ్ తో రీప్లేస్ చేస్తాం, అప్పుడు దానికి రేట్ ఆఫ్ ది రియాక్షన్ మనం క్యాలిక్యులేట్ చేస్తాం. చేసినప్పుడు ఏమవుతుంది, ఆ CD బాండ్ అనేది రేట్ ఆఫ్ ది రియాక్షన్ స్లోగా మనం ఐడెంటిఫై చేస్తాం. అంటే ఏమైందన్నమాట, ఆ CX కానీ CD బాండ్ ఎక్కడ బ్రేక్ అవుతున్నవి, రేట్ డిటర్మినేషన్ స్టెప్ లోనే బ్రేక్ అవుతుంది. దాన్ని ఏమంటాము, ప్రైమరీ కైనెటిక్ ఐసోటోపిక్ ఎఫెక్ట్. ఓకే, కమింగ్ టు ది సెకండరీ కైనెటిక్ ఐసోటోపిక్, ఇట్ ఈస్ నాట్ బ్రేకింగ్ ఇన్ రేట్ డిటర్మినేషన్ స్టెప్ లో కావట్లేదు, అంటే స్లో స్టెప్ లో కావట్లేదు. ఎక్కడైతుంది, ఫాస్ట్ స్టెప్ లో, సెకండ్ స్టెప్ లో అయితే. ఆ సెకండ్ స్టెప్ ఏంటి, నాట్ డిటర్మినింగ్ స్టెప్, అది అక్కడ ఏం జరిగినా పెద్ద పట్టింపు లేదు. జరిగేది ఇది డిసైడ్ చేసేది ఇది స్లో స్టెప్. రేట్ దాని పేరు ఎందుకు పెట్టినాము? రేట్ డిటర్మైనింగ్ స్టెప్స్. రేట్ డిసైడ్ చేసేది ఇదే కదా, తెలియజేసింది. ఇక్కడ జరిగితే ప్రైమరీ, సెకండ్ దాంట్లో జరిగితే సెకండరీ. అది సెకండ్ స్టెప్ లో జరిగితే సెకండరీ కాదు, బై వాంటెడ్ మనం చేసి చూసినాం అక్కడ, బై వాంటెడ్ చూసినాం. యాక్చువల్లీ మీరు తెలిసి చూసినా మనకి ఏమైంది, ఇది స్లో అయింది. స్లో అయిందంటే ఇది ఎంత ఉంది కదా, మనకి 37 ఇక్కడ ఎలక్ట్రాన్స్, ఇది 35. కాబట్టి ఇది ఆటోమేటిక్ గా కంపేర్ టు స్లో ఫాస్ట్. ప్రైమరీ లో ఎఫెక్ట్ ఉంది నా, కానీ అవర్ ఏం ఇస్ టు నో వాట్ ఈస్ సెకండరీ స్టెప్. సో ఇది వల్ల మనం ఇది వర్కౌట్ కాలేదు కాబట్టి దీన్ని రీప్లేస్ చేస్తాం. అది చూడండి, ఇక్కడ ఏం కాలేదు, అట్లే ఉంది మొత్తం. ఇక్కడ ఏమైంది, అయింది ఏమైంది, కార్బోక్యాట్ అనేది ఫస్ట్ స్టెప్. వాట్ హ్యాపెన్, ఫార్మేషన్, దట్ ఈస్ కార్బోక్యాట్ ఫార్మేషన్ టేక్. బట్ what before going to the product, what happened? సెకండరీగా ఏమైంది, హైడ్రోజన్ here element జరుగుతుంది. This is secondary kinetic aspect. ఓకే మేడం, ఒక్క నిమిషం నాకు అయితే ఇంకేమైనా క్వశ్చన్ కొద్దిగా స్టార్టింగ్ లో మాకు అలా ఉంది, కానీ మనం ఎక్కువ వాడాం. జనరల్ గా బ్లాక్ బోర్డ్ ఎక్కువ వాడతాం, లేదా వైట్ బోర్డ్ మార్కర్. Yeah, before ending my lecture, I will thanking Professor K. Padma Madam, Head Department of Chemistry, there at the University, and Professor Rao Sir, Department faculty member of Department of Chemistry, and my earlier colleagues, and sir, and my dear student. Thank you one and all for giving me this opportunity. Thank you very much.
Madam, please go. Addition to the tradition of your university to felicitate our guests, please take over the process by Praveen.
And
फोटोस नहीं रहे
Thank you.
The time to conclude the session. Thank you. I think we discussed yesterday what is the importance of reaction mechanism. So they are expressed yesterday, discussed about the mechanism of coumarin synthesis and tetrahydrocarbazole. During that, they are expressing that how to remember this mechanism. I said that this is not a difficult thing. Once you are habituated to this, writing all these processes, it will be a cakewalk for you. But the process required to you learn in a step-by-step manner, in a simple way, you can easily remember. Once you are expertise in it, you can write the mechanism for hundreds of reactions. By simply seeing the reaction, you can write it. But before that, you need to do so much of hard work and so much of practice on that. You need to aware of everything, every intermediate, what kind of intermediate is generated, how the intermediate can be isolated, identified, Those things you need to understand that, remember that. Based on that, you can write the mechanism for any kind of reactions, not only the known. We may be proposing for the unknown reaction mechanism, unknown reactions mechanism also. Okay, these are the extension lecture. We are the primary stage. Such extension lectures maybe will be seen coming 2 years. So many patiently participate in it, learn it, okay, implement in our life during the career. Right. This is my proud privilege and to express gratitude for their kindness for accepting these invitations. First of all, I express my thanks for our head department of chemistry, Professor K. Pramila Madam, for planning and executing all these programs. And next, I express my gratitude and love and affection towards Professor K. Sakram sir. He is also our DRC member, doctoral committee research committee member. Thank you, sir, for your kind support and involving for progress of our department activities. Thank you, sir. Thank you very much for accepting our invitation for delivering this lecture. I also thank our Dean Faculty of Science, Academic Director, Vice Chancellor, and Registrar for approving the financial and administrative sanction for conducting these kind of programs in the Department of Chemistry. I also thank our colleague Mohan Babu and Praveen. They are assisting me, though they are seniors, but they are assisting me for conducting these programs, and I am utilizing their expertise for conducting these programs. Thank you very much, Mohan and Praveen. And also I thank our computer center people. They are arranging such a program in the live YouTube also. And the YouTube 70 members are joined. Thanks for their support and cooperation. I also thank our non-teaching members in the Faculty of Science. Finally, I thank you all for participating in this program and patiently for listening, and also requesting the same support in future. Thank you very much. మీరు స్టూడెంట్ ఫోటో తీద్దామంటే ముందుకెళ్ళి దిగుతారు సార్. ఓకే కానీ పదండి దిగుతారు పదండి. ముందే అరేంజ్ చేయాలి. నా స్టెప్స్ ఉన్నాయి కదా. Yes, sir.